Hey everyone, welcome back to the channel. Today we are diving into one of the most important topics in the IGCSE ICT syllabus, the systems life cycle. If you have ever wondered how computer systems are actually developed, upgraded, or replaced in the real world, this video is for you. We'll be breaking down each stage step by step, so by the end you'll have a complete understanding of the entire process. Let's get started. So what exactly is a systems life cycle? Well, it's a comprehensive framework. Think of it as a roadmap that describes all the stages and processes involved when a company needs to replace or upgrade their computer system. This is typically overseen by someone called a systems analyst. And here's the key thing to understand: it's a continuous cycle. It just doesn't happen once and you're done. Systems need constant improvement and updating. So this cycle keeps running over and over again to ensure businesses have fully working up-to-date systems. Now, before we get into the stages themselves, let's talk about why organizations even need to upgrade their systems in the first place. There are 4 main reasons you need to know for your exam. First, obsolete equipment. Imagine trying to fix a computer from the 1990s today. Sometimes the equipment is so old it simply can't be repaired or maintained anymore. Second, legal or tax changes. When governments change tax laws or introduce new regulations, companies often need major software overhauls to comply. Third, more efficient and reliable hardware becomes available. Remember, technology tends to advance rapidly, and the newer systems can do the job better, faster, and more reliably. And finally, business expansion and growth. When a company grows, their old system might not be able to handle their increased workload. So they need something bigger and better. Now, let's look at the big picture. The system's life cycle consists of 6 core stages, and they happen in this specific order. Stage 1, analysis, where we research and understand the current system. Stage 2, design, where we plan the structure, inputs, and outputs of the new system. Stage 3, development and testing, where we actually build the solution and verify that it works. Stage 4, implementation, the transition to the new system. Stage 5, documentation, creating all the technical and user guides. And finally, stage 6, evaluation, where we assess the performance and identify any improvements needed. Remember, after evaluation, the cycle can start all over again if more improvements are required. Each stage is crucial and they all build on each other. Let's dive into stage 1, analysis. This is where everything begins. The main goal of the analysis stage is to thoroughly understand how the existing system operates and how to identify the specific requirements for the new system. Think of it as doing your homework before making a big decision. You wouldn't buy a new phone without researching what features you need, right? It's the same principle here, but on a much larger scale. The systems analyst needs to gather comprehensive information from multiple sources to really understand what's needed. So how does the systems analyst gather all this information? There are 4 main research methods you need to know. First, observation. This means actually watching personnel as they use the current system. It gives an overall view of how things work and it's relatively inexpensive. However, there is something called the Hawthorne effect to watch out for. People might behave differently when they know they are being watched. Second, interviews. These are one-to-one sessions that allow deep exploration of specific aspects. They are great because they can motivate honest, detailed answers and you can ask follow-up questions. Third, questionnaires. These can be distributed widely to gather diverse perspectives from lots of people. They are cost-effective and allow for anonymous responses, which means people might be more truthful. And fourth, document examination, reviewing existing documentation. This involves reviewing existing files, accounts, and manuals to help you determine the scale of the system and what memory requirements might be needed. At the end of the analysis stage, there is a critical deliverable you need to know about: the functional requirement specification. This is essentially a detailed document that lists all the hardware and software requirements needed for the new system. It's like a shopping list and blueprint combined. This document is absolutely vital because it guides everything that happens in the next stages. Without a clear requirement specification, the design team wouldn't know what to build. Now, moving on to stage 2, design. This is where we take all those findings from the analysis stage and transform them into detailed technical specifications. The design stage defines exactly how the system will function and how it will interact with the users. If analysis was about understanding the problem, design is about planning the solution. Let's talk about file and data structures first. Every single field in the database needs to be completely defined. This means specifying the data type for each field. Is it alphanumeric, real number, currency, date, or Boolean? You need to be precise here. Also, every record needs a unique primary key field. This is a field that uniquely identifies each record in the database, like a student ID number or an employee number. Getting these structures right is fundamental because if your data structure is poorly designed, the entire system will have problems. Next up in the design stage, we have input and output formats. Screen layouts and data capture forms need to be carefully designed for efficient data entry. Think about it. If a data entry clerk has to enter hundreds of records a day, the form needs to be logical and easy to use. On the output side, we need thoughtful planning of screen displays and printed e-reports. This includes choosing appropriate fonts, colors, and field sizes. The goal is to make information easy to read and understand. A poor design here can lead to errors and frustrated users. The final crucial element of design is validation routines. These are automatic checks that ensure data quality before it's accepted into the system. There are several types you need to know. Length checks make sure data isn't too long or too short. Presence checks ensure required fields aren't left empty. Format checks verify that the data follows the correct pattern, like making sure an email address has an @ symbol. And check digits verify numerical data is entered correctly. And many others. These validation routines are your first line of defense against bad data entering into your system. Now, we reach stage 3, development and testing. After the design has been approved, it's time to actually build the system and rigorously test it. The keyword here is rigorously. Testing needs to be thorough. Why? To ensure the system is robust, accurate, and functional. Modern development often uses something called modular design, where programs are broken into smaller components. Each component is tested individually before they are all integrated together. This makes debugging much easier. Testing is so important that you need to understand the different types of test data used. We have 3 main types. Normal data. This is acceptable, valid data that should work perfectly. For example, if a month field should accept values from 1 to 12, normal data would be something like 3 or 10. Extreme data. This is data at the very limits of what's acceptable. For our month example, that would be 1 or 12. The system should accept those, but they test the boundaries. And abnormal data, this is data outside the limits that should definitely be rejected. Examples from my example would be 0, -1, 45, or the word July when the system expects a number. Testing with all three types ensures your validation is working properly. There is also something called live data testing. This involves taking actual data from the old system that are known with known outcomes and entering it into the new system. Then you compare the results from both systems to verify accuracy. This is really important because it uses real-world data, not just theoretical test cases. If the new system produces different results from the old system with the same data, you know there's a problem that needs to be fixed before implementation. Stage 4 is implementation. This is when you actually transition from the old system to the new system. This is a critical and often stressful stage because organizations are dependent on their computer systems. If something goes wrong during implementation, it can be disastrous. That's why there are 4 different changeover methods to choose from, each with its own advantages and disadvantages. Let's look at direct changeover first. With this method, the old system is stopped immediately and the new system starts up overnight, like flipping a switch. The advantage is that you get immediate benefits from the new system, and it's the least expensive method because you're not running 2 systems. However, the disadvantage is huge. If the new system fails, it's a complete disaster. There's no backup. This method is only used when the organization is very confident in the new system and the risk of failure is considered very, very low. Next is parallel running. With this method, both the old and new systems run simultaneously for a period of time. The major advantage is that if the new system fails, the old system is still there as a backup, so the organization can keep functioning. This is the safest method. The disadvantages: it's expensive because you are essentially running 2 systems at once. And it's also time consuming because staff have to enter data into both systems and compare results. Despite the cost, many organizations choose this method because it's the lowest risk. Third, we have pilot running. With this approach, the new system is introduced in just one branch or department first, while the rest of the organization continues with the old system. The advantage is that if there is a failure, it only affects one branch, limiting the damage. The disadvantage is that you only get a partial initial assessment. Problems specific to other branches may not show up until later. This method is good for large organizations with multiple locations. Finally, there is phased implementation. The system is introduced in stages with each stage being validated before moving on to the next. For example, you might implement the inventory module first, make sure it works, then implement the sales module, and so on and so forth and so on and so forth. The advantage is that you ensure proper function before expanding to the next phase. The disadvantages are that it's more expensive and time-consuming than direct changeover. However, it's less risky than direct and allows you to learn from each phase. Moving on to stage 5, documentation. Comprehensive documentation is absolutely essential for both system maintenance and user adoption. There are 2 distinct types of documentation you need to know about, and they serve very different audiences and purposes. Technical documentation is for programmers and IT staff who need to maintain and update the system. It includes things like source code, database structures, and system architecture. User documentation is for the end users, the people who will actually be using the day-to-day system. This includes user guides, tutorials, and help files written in non-technical language. Both types are crucial for long-term system success. We have reached the final stage, evaluation. This is where we assess whether the new system actually meets the original requirements and performs as expected. The evaluation stage is critical because it identifies any limitations and necessary improvements. And here's the key thing: evaluation can potentially trigger a whole new cycle. If major problems are found, you may need to go back to the analysis stage and start again. That's why we call it a cycle, not just a linear process. Now, there are several evaluation methods that can be used. First, observing users performing typical tasks helps identify usability issues. Maybe a screen is confusing or a process takes too many steps. Second, measuring task completion times allows you to compare the old system versus a new system efficiency. Is it actually faster, or did we make things worse? Third, conducting interviews with stakeholders provides qualitative feedback. What do people actually think about the new system? And fourth, distributing questionnaires gathers widespread user experiences from lots of people across the organization. All these methods together give a comprehensive picture of whether the system is successful. All right, let's wrap things up with the key takeaways you absolutely need to remember for exam. First, the system's life cycle is iterative. It runs continuously, with evaluation potentially triggering new cycles of improvement. It's not a one and done process. Second, each stage builds on the previous one. Analysis informs design, design guides development, testing validates implementation. You can't skip stages or do them out of order. Third, multiple stakeholders are involved. Systems analysts, programmers, users, and management all play crucial roles. It's a team effort. And here are the final three key takeaways. Documentation is essential. Fourth, documentation is essential. Both technical and user documentation ensure long-term system success and maintenance. Without good documentation, the system becomes difficult to maintain and use. Fifth, testing prevents costly failures. Rigorous testing with normal, extreme, and abnormal data ensures system reliability. Never skip testing. And sixth, implementation strategy matters. You need to choose the changeover method that best balances risk, cost, and organizational needs. There is no one-size-fits-all approach. And that's a system's life cycle. You now understand all 6 stages from analysis right through to evaluation, and you know why each stage is crucial for developing successful computer systems. Make sure you can describe each stage, explain the different research methods, identify the types of test data, and compare the 4 changeover methods. These are all common exam questions. If you found this video helpful, please give it a thumbs up and subscribe for more IGCSE ICT content. Drop any questions in the comments below and I'll do my best to answer them. Good luck with your revision and I'll see you in the next video.